Hello, hello, hello. If you are watching this, you are confused as to why it says I'm muted. Hello, 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 everybody. If you're watching this, then you missed week or day one of our week 7 class, and you're catching up. Let's get to it. This week we talked about Internet Protocol. We finished our discussion from last week. And then we talked about packets and how we can make the internet reliable. There is an assignment titled 020501 due next Wednesday, the 14th by midnight. Our objectives for today were to describe how information flows through the internet in terms of packets, explain how packet numbering and reordering can allow for large messages to reliably be sent, and how packets being dropped does not affect that. And then we explain the differences between TCP and UDP and how you can identify them. So overall, everything we're talking about really harkens back to this model right here. Now, you're not expected to memorize this particular model for the class, but if you take future college classes, for instance, you're definitely going to be using this a lot and you will end up memorizing it. On the bottom, we have very physical or very literal things. So the bottommost layer is the physical layer, actual wires that exist in the real world. As you go up the model, you get more and more abstract, meaning the things up here really rely on the protocols below them to perform their job without really worrying about how that job gets done. All they know is everything below them should, in theory, work properly. So we didn't really talk about these really basic things that you might see in the data link layer, but we are interested very much in the internet layer and the transport layer. The internet layer has this beautiful protocol called the Internet Protocol, which we already mentioned. This is what numbers every single machine out there and allows them to communicate successfully by addressing the information to a specific number that corresponds to the machine of their choice. Today we're going to be looking into these two protocols as well, TCP and UDP, and these will have to do with splitting information apart into smaller chunks called packets and reassembling them once they reach their destination. So to sum up IP addresses in the real world, we use IPv4, which has 32 bits to address every machine. And we're switching currently to IPv6, which is going to have 128 bits and is going to allow us to number every single grain of sand, and therefore should be sufficient numbers to last us, a long, long time, for sure. Maybe until the end of humanity as we know it. All right, so what did we do today? We went to code.org and checked out lesson 4. You can do this yourself. Simply open 2 tabs and you can join the router of your choice twice and see how this works. We were able to look at the router logs to see how information travels through the network. We noticed a couple of things. First of all, not every single message you send out necessarily gets to its intended destination. Sometimes the router will drop it. Second of all, when you send a piece of information from one router to a different router, it doesn't always go there the same way. It might bounce among several different routers to get there, and its path could be different every time. Both of these things are true of the real routers in the real world. Information travels among them in different paths, and you can never predict the path ahead of time. Similarly, information is sometimes dropped. When a router is overwhelmed or something unexpected happens, it's possible for a piece of information to get lost. So how do we combat these two issues? Or, well, the last is an issue, the first one is a feature. How do we combat that issue? We have something called packets. Let's take a look at what packets are. So, suppose you're cleaning out your school library. You have 2 choices. You can either grab all the books and just shove them indiscriminately and hope it all works out, or you can meticulously write down where every book goes. Those are kind of the 2 approaches to making your packets when you are sending things over the internet. The first approach we're going to call UDP, where you send some packets and you hope they can make it to their destination, and you don't spend a whole lot of extra redundancy or time trying to make sure that they do. The second approach is called TCP, and that one ensures that everything gets to where it's supposed to go through meticulous error checking. So that is what we talked about today. Now, inside lesson 5, level 2, there is a widget for you guys to check out. Let me show you how it works. It's important that you look at this one, if not the other one, because it's good to see this whole thing be simulated. So let's see. If we go to bubble 2 here, now because I don't have a partner, I am going to have to open up 2 separate tabs in order to do this successfully. So let me open up 2 separate tabs so I can connect to myself, and you guys can do this yourselves as well. Now, let's see here. Obviously, this would be no fun with just one router. Let me add a couple of routers. All right, so I'll join router 1 and router 3. All right, router 1 has me as 1.6, whereas the other router has me as 3.13. Those are my IP addresses. So if I send something to 3.13 right here, and I say, "Hi, how are you?" you'll notice that the message doesn't actually get sent the way I intended. That's because it's too long. We now have a packet size limit of 80 bits. Notice 16 of those are already taken up by our metadata, the to and from information. So we need to account for that. So I could send a much shorter message like "Hi, how, and then "Are you?" could be a separate message. So if I send both, in theory, I should be receiving them on the other end over here, and I do. However, you might not receive them in the proper order. And in fact, if you look over here, sometimes a message will also get dropped, and you can show all routers to see exactly the path that these messages take. So for instance, this message never got to me. It got dropped on the way over. So the assignment that we worked on this week was found on MyMCPS. So let's go ahead and open it up. If we go to MyMCPS, navigate to modules, and underneath week 7, you'll find it posted right here, packets. Let's take a look at the assignment itself. Your task is to solve this issue of dropping packets. So you need to answer these couple of questions at the top, but also you need to come up with a systematic approach for sending information and knowing if the other person got all of it, and also combating this issue where sometimes packets get dropped. We need to get all of our information in order to proceed. So one approach that you might want to consider would be numbering your packets. Further, you need to let the other person know how many packets they're expecting. If I just number my packets, but they missed the last couple, they have no way of knowing how many they should have gotten. So you should communicate clearly both the number of the packet and also how many packets total I should be expecting. Lastly, you need to have in place a system to request the packets you're missing. How do we get those packets that we dropped? You have something in place for that. All right. So that was the main activity for today. Hopefully you can work through that yourself if you aren't here, and email me through any questions you have. These are important things to note. Packets can take different paths. Messages may arrive out of order or be incomplete. And you need a protocol in place that is strong enough to be able to reassemble the messages. We have 2 protocols that do this in real life. One is called User Datagram Protocol, or UDP. This is when you want to send something very, very fast. Something like live streaming or video conferencing, where if we miss a piece of information, it's not the end of the world. We can easily catch up or get that information again from the other person. For things that are photos, emails, or something very clear and specific that we expect to load properly the first time, we use TCP. This is where we double check that everything we're sending is actually correctly being received on the other end. So you need to know the difference between these two. I highly recommend you check out this video posted inside my slides. It has a lot of useful information. And these are some thoughts that you should probably have in your mind, leaving this lesson and moving forward. These terms will also be on a journal coming up, so you should probably take notes of what they mean right now. All right, that's it. I hope to see you guys in class next Thursday. Have a good one.